Many consider science and art to be completely separate, even totally opposite disciplines. We tend to think of art as being intuitive and emotional, while science is rational and objective. Both fields, however, are exploratory in nature and involve extensive trial and error. Art and science interact more often than you might think. Some artworks openly celebrate scientific achievements, while some artists have even used scientific methods to make art. The appreciation of art relies, of course, on the human senses, and artists have always been particularly keen on manipulating the perception of those viewing an artwork. Science and technology also play an important role in the restoration and conservation of works of art as well. Renaissance artist Leonardo da Vinci was not only a painter, but also an engineer, anatomist, botanist, and mapmaker. His sketchbooks were full of ideas and images, illustrating both his speculative thought and careful observations. Amongst his explorations, Leonardo dissected human bodies and drew what he saw. He also studied the works of other artists and observed the effects of light and shadow on a form. His drawing, Vitruvian Man, shows the artist's interest in the proportions of the human body. The mirrored writing above and below the drawing, readable when reflected, consists of Leonardo da Vinci's notes based on the ideas of the 1st century BCE Roman architect Vitruvius. Vitruvius was an architect, engineer, and the author of 10 books on architecture, the only surviving treatise on architecture from the ancient world. In this treatise, Vitruvius outlined the ideal proportions of a man and argued that architecture should imitate these proportions. In Leonardo's drawing, the length of both arms combined is equal to the height of a man. The distance from an elbow to the tip of a finger is 1/4 the height, and a man's foot is 1/7 his height. Leonardo also made his own observations of the human body, frequently, again, studying corpses to determine whether the writings of Vitruvius were accurate or not. Inspired by Vitruvius, architects often combine the geometric shapes of squares and circles to suggest harmony in both a building and between heaven and earth. By placing the figure inside both a circle, which represents the cosmos or heavens, and a square, which represents the earth, Leonardo is also suggesting an equilibrium in the human body as well. The scientific revolution really began in the Renaissance, as evidenced by Da Vinci's studies, drawings, and inventions, but in the late 17th and 18th centuries, a philosophical movement known as the Enlightenment rejected traditional, particularly religious authority in favor of rational and scientific inquiry into all aspects of human life. Enlightenment values shifted away from traditional religious or folkloric explanations of the universe towards empirical scientific understanding derived from observation, investigation, and experimentation. In this era, before the invention of photography, artists were uniquely skilled to create images based on what they saw, and the relationship between art and science grew even closer. British artists of the 18th century were particularly fascinated by the drama and romance of science inspired by these Enlightenment ideals. Joseph Wright of Derby set up his painting studio during the first wave of the Industrial Revolution, and he catered to many self-made, wealthy industrial entrepreneurs. Wright himself was a member of the Lunar Society, a group of industrialist merchants, traders, and progressive aristocrats who met monthly to discuss science and technology. Wright often painted romanticized scenes of public experiments and demonstrations in an effort to increase the public's interest in science. For example, this work from 1765 depicts a philosopher, which was the equivalent of a modern scientist, giving a demonstration at an orrery, a mechanical model of the solar system. Because of 16th century and 17th century discoveries by Galileo, Copernicus, and Kepler, humans now knew that the planets in our solar system do not orbit Earth, but rather all of the planets orbit the central sun. An orrery used a gas lamp to represent the sun, and it kind of demonstrated planetary movements. The philosopher here is shown in a rich red coat as he shares his knowledge, and we have attentive students to the left kind of taking notes. The men on the right seem to be listening very closely, and the children are fascinated by the orrery itself. The dramatic lighting and rich colors help to increase the drama and emotional response of this work as well. Here's another example by Wright. This time, the scientist performs an experiment using a newly developed air pump, which was used to study the properties of gases, but also made for dramatic public demonstrations. Here, air was pumped out of this glass vessel near the scientist's head until the bird inside collapsed from a lack of oxygen. Then, the scientist opens a mechanism at the top of that vessel to allow air back into the vessel before the bird dies. So he's demonstrating the properties of gaseous oxygen and its necessity for life, but in a rather dramatic, sort of emotional way. And Wright depicts a tense moment of the experiment just before the scientist allows air back into that chamber. The professor is kind of emerging from the darkness, gesturing dramatically, kind of like a magician on stage. Again, we have this attentive crowd, while the young girls to the right are having a more sort of personal, emotional response. Wright's message here is that science is wondrous and exciting, and if done correctly, it can allow for discoveries about matters of life and death. Both women and men played significant roles in the scientific revolution, making important observations and discoveries and creating new knowledge along the way. Mary Delaney brought her artistic talents to the observation of the natural world. Late in their lives, Delaney and her friend Margaret, Duchess of Portland, embarked on a project of classifying the Duchess's substantial botanical collection according to the taxonomic system of Swedish scientist Carl Linné, who divided plants into classes according to their physical properties. Delaney created a series of nearly 1,000 extraordinarily detailed, visually descriptive, and botanically accurate cut paper collages of plant specimens. These show her careful study of the form and structure of plants. She sets the paper cutout against a black background to increase both the visual impact and the viewer's ability to discern small details of the plant's texture, color, and structures, such as the number and forms of the stamen and the pistil of the flower. Delaney layered the paper in such a way that it projects ever so slightly from the black surface, creating a very subtle three-dimensional effect as well. Artists study anatomy to learn how to depict figures as accurately as possible, and many artists have become interested in dissection and medical procedures. Da Vinci was one of the earliest known artists to do so, but many others have followed in his footsteps. American painter Thomas Eakins was a student at the first American Art Academy, the Pennsylvania Academy of Fine Arts, but he felt the anatomical training that they offered was lacking, and he supplemented his knowledge with studies at the nearby Jefferson Medical College. In 1876, he was hired as a teacher at the Pennsylvania Academy, and by 1882, he had been appointed as director. Eakins promoted the study of anatomy through drawing from life, photography, and the observation of dissection instead of the traditional methods of studying plaster casts and classical nude figures. His artistic style has sometimes been dubbed scientific realism because of his uncompromising desire to portray honest, accurate details. He was also inspired by Edward Muybridge's studies of horses and humans in motion, and so he created his own photographic studies in which he superimposed several exposures of a jumping man onto a single negative to help him sort of understand human anatomy for his paintings. He also projected photographs onto canvases to trace figures and shift objects around to make a more harmonious composition with incredible detail. However, his teaching methods were considered quite controversial because they deviated from those traditions, and eventually he was forced to resign from his position. One of Aiken's most controversial paintings was his 1875 work titled The Gross Clinic, which was created specifically for the 1876 Philadelphia Centennial Exhibition. But because the jury felt it was a subject unfit for the fine art exhibition, it was shuffled over to the scientific and medical display. Aiken's large canvas depicts the local physician, Dr. Samuel David Gross, overseeing a surgery and lecturing to a class of medical students, including Aiken's himself at the far right, who can be seen sketching and taking very detailed notes. At this point in time, surgeons, especially teaching surgeons, were somewhat feared as inhumane beings who used the poor as objects to practice on. An idea that is quite highlighted by the kind of visceral reaction that the woman to the left is having. This is probably a relative to the patient, maybe the mother, and she sort of cringes in horror at this bloody procedure, although in reality she would have probably not been present for the procedure itself. Aiken's is sort of attempting to focus on the heroism of the surgeons, illuminating Dr. Gross's face and his bloody, scalpel-wielding hand. The strong, clear light highlights the patient prominently. However, Aiken sort of dehumanizes the patient by presenting only a portion of the leg and the rear end, his socked feet, and a jumble of sheets, instead he does emphasize the attentive skill of the doctors who are working. The goal here was to celebrate scientific achievement and document the medical procedures and advancements of the time. In this case, Aiken's recorded a surgical innovation that allowed Dr. Gross to save this patient's leg when previously it would have just been amputated. The attention to detail makes this a useful historical document of the procedure. For example, he shows the use of anesthesia. You can see the anesthetist holding a white cloth over the patient's face, and without this innovation, this procedure would not have been possible. Aiken's also uses theatrical lighting to heighten the emotional impact, and again, kind of including the patient's distraught relative also helps to kind of heighten the emotionality of the scene. The detailed observation of the procedure that Aiken's performed kind of created such a brutally realistic depiction that a critic for the New York Daily Tribune commented, quote, "It is a picture that even strong men find difficult to look at long, if they can look at it at all." Sometimes artworks are created as a form of science experiment, maybe as a record or result of the process. For example, American Harold Doc Edgerton was an electrical engineer, but his work led to some stunningly beautiful photographic images. Edgerton explored the changing processes of phenomena such as the movement of a bullet, the explosion of a hydrogen bomb, the flapping of a hummingbird's wings, etc. To capture details that could not be seen with the naked eye, he invented an electronic stroboscope, which produces short bursts of light, and combined with this technology, camera shutter motors. In this particular work, titled Milk Drop Coronet, the stop-motion technique was able to capture on film the microsecond when a drop of milk hit a table, or in this example, a red plate. Edgerton worked on studies of droplets, which were originally produced only in black and white over a period of 2 decades. Of course, here this has been reproduced in color, which I think really adds to the contrast and the detail. So bioart is that which reflects the passage of time through the natural processes of growth and decay that organic materials undergo. Work by bioartists is always changing. So examples of bioart would serve as great examples for the theme of cycles of life. However, oftentimes, artists incorporate organic or biological materials into these works, and so there's a crossover between art and science here as well. In her work, Astroculture, Shelf Life, the American bioartist Suzanne Anker experiments with how plants might react in such artificial conditions as those necessary to sustain life in outer space. In this case, the artist has used red and blue LED lights to provide the equivalent of nourishing rays of sunlight, reducing the amount of light and energy required. Even though the leaves would appear green if under normal light, in this environment they appear a strong magenta color. The artificial conditions eliminate the need for insecticides and result in lower carbon emissions, and are therefore a practical option for artificial growing conditions in outer space. Anker's work really blurs that line between science and art, contributing to our understanding of the universe while also delivering interesting and colorful visual forms and sort of serving as a science experiment itself. Continued advancements in the biological sciences have allowed the field of bioart to develop further. In order to illustrate that white rot fungi can be used by society to consume plastic debris, artist Elizabeth Demari developed with her students at the John Dighton Lab at Rutgers University something which she calls the plastomic, or plastic-eating stomach. Shown in the kitchen gallery of Swale House, an art and science collaborative on Governor's Island, New York, the exhibition invited people to bring their plastic waste and feed it to this living sculpture. Titled "Home is Where the Plastic-Eating Stomach Is," this community art action encourages us to view our waste products as a resource. Expanding the habitat of fungi into our own living spaces may allow us to eliminate our plastic footprint. Demari creates many projects that explore trans-species giving, a concept that suggests that the similarities between living organisms mean that we can help other life forms and vice versa. The fascination created by looking at the changes within the piece and the high level of participation by an audience, again, kind of blur the lines between artwork and scientific project. For the project called Stranger Visions, the American artist Heather Dewey Hagborg gathered objects from the streets of New York that had been touched by humans, such as gum or cigarette butts, or discarded material from the human body itself, such as hair. She analyzed the DNA found on these samples, and using that information, she was able to determine genetic characteristics such as eye color, hair color, gender, and race. And then using a 3D printer and this genetic information, she created models of their faces. Dewey Hagborg says, quote, "I was really struck by this idea that the very thing that makes us human, hair, skin, saliva, fingernails, becomes a real liability for us as we constantly shed them in public." Because Dewey Hagborg was able to gather and reproduce only general qualities from the DNA due to her limited skill and equipment, her work highlights concerns about privacy and DNA profiling as the field of genetic research continues to grow. Advancements in science and mathematics throughout history have enabled artists to create new kinds of art. Islamic artists use geometry and mathematics to mimic complex forms found in nature. The Arabic term muqarnas means stalactite vaults, or the drips of calcium salt found within caves. Muqarnas are decorative elements in Islamic architecture made by combining individual cells in various mathematical combinations to create a structure resembling a honeycomb. A spectacular example of muqarnas can be seen in this image, which is of the entrance portal, or Iwan, to the Masjid-i-Shah Mosque in Isfahan, Iran. The seemingly inexplicable complexity of the design helps visitors to kind of feel the holy space as they enter, almost as if they're moving through an otherworldly gateway. And the muqarnas are, in fact, used to mark transitions into holy spaces, and they frequently cover domes inside of large mosques. The geometric shapes resemble a series of small domes, sort of lined up in rows and stacked up on top of one another. One description suggests that the muqarnas sanctify the space by symbolizing, quote, the rotating dome of heaven. The repetitive forms and glossy tiles reflect light in multiple directions, symbolizing spiritual light filling the space. As early as in ancient Greece, artists desired to create artworks that would fool viewers into believing what they saw in a painting was actually real. As we've talked about a little bit before, this technique is now referred to as trompe-l'oeil, from the French meaning to deceive the eye. So this is a visual illusion in art in which a painted image appears as a three-dimensional object to the viewer. The Greek painter Zeuxis was said to have painted such convincing grapes that birds flew into canvases trying to eat them. Beginning with the invention of linear perspective in the Renaissance, artists tried to create canvases that were illusionistic windows, or they suggest a depth that appeared to be as real as that in nature. The British artist Julian Beever applied a special form of trompe-l'oeil known as anamorphosis to his sidewalk art. An anamorphic image is one that is stretched and distorted, but that becomes clear and realistic when viewed from a single oblique angle. Beever's chalk drawings confront passers-by with what appear to be convincing scenes that take place in three-dimensional spaces. For example, when his woman in pool is viewed from the right vantage point, it appears that a woman is lying back in a swimming pool, drink in hand, kicking her leg into the air. But when it is viewed from the opposite direction, the illusion is destroyed, and one can see that Beever used extreme foreshortening to represent the woman's leg. The only genuinely three-dimensional element in the photograph of the illusionistic drawing is the artist themselves, and they're holding a drink, and he has his foot kind of placed flat on the pavement there. For many millennia, the regular yet ever-changing night sky has been a source of endless fascination and study. In ancient Mexico, amongst the Maya and Aztecs, the planets were regarded as gods, and their movements were closely monitored. Some of the most fascinating artworks of the Maya and Aztec empires reflect this interest in astronomy. The flint that is seen in this image incorporates elements of the cosmology, or the beliefs about the origin of the world, as well as the astronomical knowledge of the Maya. The delicate carving of this very hard stone reveals a high level of craftsmanship as well. Light enough to be held in one hand, the flint depicts the story of creation, said by the Maya to have occurred precisely on August 13th, 3114 BCE, when, according to Maya belief, the first father was sacrificed after losing a ball game against the Lords of Death. The first father's soul is seen riding a crocodile to the Maya underworld, known as Xibalba, and he is accompanied by other Maya lords. The profiles of the first father and two of the lords, they appear on top of the crocodile, kind of leaning backward to suggest the speed of the journey. Two additional figures are shown facing downward toward the underside of the crocodile, and the serrated edge on the bottom of the flint represents the forceful waves encountered on the journey. The moment shown here is the transformation of the crocodile into a sacred canoe just before it dives through the rough waters, signifying the death of the first father. Soon thereafter, the first father will rise from the waters, transform into the maize god, and become the creator of humans. This flint, however, is much more than a depiction of a Maya story. It is also an instrument for astronomical observation. When the object was held up to the sky each year on August 13th, the 5 heads on this flint align with the brightest stars of the Milky Way galaxy. For the Maya, the stars reenact the story of man's creation when, at midnight, the stars of the Milky Way galaxy align horizontally east to west. Over the next several hours, the galaxy appears to pivot and sort of fall out of the sky, resembling a canoe diving into water. Then, immediately before the sunrise, the 3 stars of the constellation known as Orion's Belt appear, symbolizing for the Maya the 3 hearthstones at the site of first father's rebirth. So it's not only depicting that story, it can also be used to kind of track the movements of the cosmos on August 13th, and therefore kind of reenact that story with the stars. The fascination with outer space continues in modern times, and many contemporary artists have depicted space exploration and astronomical discoveries, as well as images of the planets, the galaxy, and beyond that have been kind of taken and posted by NASA. This infrared image of the Orion Nebula from the Herschel Space Observatory shows how scientific instruments and data visualization techniques can combine to produce beautiful imagery of astronomical phenomena that we would otherwise be unable to perceive. The light blue areas here indicate what can be observed in visible light, while the red and orange filaments of dust, which would normally appear dark and opaque to the human eye, were mapped using spectrographic data, and the resulting effect is that of a painterly sky or seascape, reminiscent of maybe 18th or 19th century landscape paintings. Because art is a visual medium, artists expect viewers to respond to their work through their sense of sight. It's not surprising, therefore, that artists have often been keenly aware of scientific studies of visual perception. Some artists have experimented with ways to use their images to trigger responses from other senses, such as hearing or smell, and other artists have tried to express visually their personal experiences or maybe portray their subconscious. Now, we've already discussed this work a bit back when we were talking about color, but to refresh your memories, this is Sunday on La Grande Jatte, which is a picture of people engaged in the activities of everyday life created by the French artist Georges Seurat. However, the artist also applied to this artwork recent scientific studies on the ways that human eyes perceive color. Seurat developed a process called pointillism, which was a meticulous way of applying color theory to his works. He relied on two optical effects, optical mixture and after-image effects. He created scenes in which the figures are very distinct, almost like cutouts, because of the precise ways in which he applied tiny dots of color to the canvas. The colors that you can see when you view Sunday on La Grande Jatte from several feet away are quite different from those you would see up close. For example, the green grass is made up of dots not only of various shades of green, but also of oranges and purples. Seurat took 3 years to paint this work, meticulously applying dots while considering the effects of color theory on his palette choices. To ensure that the optical arrangement would not be disrupted when the painting was framed, Seurat also painted a border using that same pointillist technique. The American artist Jasper Johns also plays with optical effects and makes us take a second look at familiar subjects, objects the artist says are, quote, seen but not looked at. He tends to use iconic images like numbers, letters, targets, and, as seen here, and maybe most famously, the American flag. In this version of flags, Johns used his knowledge of color theory to create an optical illusion that forces a viewer to stare intently at an image of the flag. The top flag is made up of black and green stripes, while black stars are placed on a background of orange. These colors are complementary to the white, red, and blue colors of the American flag, and John's optical effect depends on the use of these complementary colors. The rectangle in the bottom half of the painting is just a faded ghost of a flag. For the optical illusion to work, stare at the top flag for a full 60 seconds. Focus your attention on the white dot in the center. After a minute has passed, blink and look at the black dot in the center of the lower flag. The red, white, and blue of the American flag will appear more brilliantly. Johns is utilizing the science that lies behind after-image effect. While looking at the top flag, your eyes become fatigued from the colors. Therefore, when you blink your eyes and look at the lower flag, your eyes produce the complementary colors of each aspect of the upper flag instead. Some artists use visual tricks that deceive our eyes into believing there is motion as time passes, even though there is no actual motion occurring. For example, this sort of illusion of motion is the basis for op art, which is short for optical art. During the 1960s, op art painters experimented with discordant positive-negative relationships. There's a noticeable sense of movement here in this work titled Cataract 3 by the British artist Bridget Riley. If you focus on a single point in the center of the work, it appears that there is an overall vibrating motion. The optical illusion sort of grows out of the natural physiological movement of the human eye. We can see it because the artist uses sharp contrast and hard-edged graphics set close enough together that the eye cannot compensate for its own natural movement. Riley understands that the natural oscillation of the eye combined with the passage of time makes us feel a sense of motion, even though this is a static, two-dimensional artwork. Many artists throughout history have either claimed to have or have been sort of theorized to have something called synesthesia. This is a process by which stimulation in one sense causes experiences in a different sense. For example, visualizing colors when you hear music. That is synesthesia. For Vasily Kandinsky, music and color were very much intertwined, both being perceived by vision and sound simultaneously. He titled many of his paintings compositions or improvisations and associated different colors with specific instrumental sounds, creating an orchestra with his paintbrush. In his treatise Concerning the Spiritual in Art from 1911, Kandinsky associated each color with specific sensations. For example, he describes yellow as aggressive with a shrill sound, whereas blue he perceives as having the potential for profound feeling. Each hue is also influenced by the addition of black or white. Light blue is described as sounding like a flute, while a shade of blue would sound like a cello or even a double bass. Composition number 7 is a complex abstraction that combines color and form into a harmonious symphony that is meant to be both seen and heard, at least to a certain extent. This 1992 photograph titled Cello Music by Marcia Smilek captures the essence of the movement of water. However, she used more than her sense of sight to create this work. Like Kandinsky, Smilek experiences life through synesthesia. Again, the physical process by which stimulation of one sense causes experiences in a different sense. Smilek describes her experience saying, quote, "The way I taught myself photography is to shoot when I hear a chord of color. I hear with my eyes and see with my ears." Of the photograph Cello Music, Smilek says, quote, "I walked by the water and heard cello. I couldn't resist the sound, so I gave in and aimed my camera at what had elicited it. As soon as I let go of my thoughts, the texture of the water washed over me in sync with the sound and turned to satin on my skin. When I felt myself climb into the shadows between the folds, I snapped the shutter. I hear cello every time I look at it today, though I discovered that if I turn it upside down, it becomes violin." Scientific advancements not only enable the creation of new artworks, but they also help to improve the way experts can restore and understand older artworks. Through the use of new technology, scientists have been able to study the layers of painting, both by using X-rays and by analyzing minute paint samples. The impetus for such studies is usually to determine how best to preserve or restore a work of art. Scientists, however, often make discoveries that offer new information to art historians about an artist's creative process or the circumstances surrounding a commission as well. Some of the most momentous restorations in recent times have been the cleaning of the frescoes at the Vatican in Rome, Italy. The restoration of Michelangelo's Sistine Chapel ceiling, which began in 1980, took 9 years to complete, twice as long as it took Michelangelo to paint the ceiling originally. In order to decide how best to clean the frescoes, restorers first had to determine what was original and what was due to the effects of time, such as candle smoke, the interventions of previous restorers, rain damage, the settling of building foundations, and even bacteria introduced by visits of millions of tourists. Scientists analyzed the chemical compositions of minuscule samples of the paint, glue, wax, and varnish taken from the many layers they found on the ceiling. This analysis, along with their ability to examine the entire work at close range, led them to believe that Michelangelo had painted the ceiling almost entirely in buon fresco, when the plaster was still wet, with only slight corrections executed a secco after the plaster had dried, and that all other layers were later additions. The most shocking discovery revealed after centuries of dirt were removed was the bright colors that Michelangelo had used. Critics denounced the cleaning as a disaster, accusing the restorers of removing Michelangelo's original varnish. An international committee of the world's leading art conservators, however, reviewed the approach taken by the restoration team, and after a lengthy inspection of the restorers' research, methods, and handiwork, the panel declared that the team had been thorough and painstaking, and that their approach was accurate and correct. The original paintings had indeed been this bright. Johannes Vermeer is known as a meticulous painter who created still, peaceful images, frequently showing women alone in their homes. As a father of 15 children, Vermeer had difficulty making a living as a painter, particularly considering the amount of time he took to finish a single work. He created fewer than 50 paintings in his lifetime, including this one, Girl Reading a Letter at an Open Window. As the girl gazes down at her letter, we notice the implied texture of the tapestry behind her and on the curtains in the room, the fruit on the tapestry, the nail heads on the chair, and the reflection of the girl and the curtain in the window beside her. The wall in the background is empty except for a shadow created by the open window. In 1979, X-rays revealed an image that had been on the back wall but had since been covered up. Scholars assumed, because of the harmonious final composition, that Vermeer had decided intentionally to cover up an idea he had planned for that wall. However, when restorers began to study the chemistry of the paint in 2017, they realized that the layer that showed a blank wall was painted not by Vermeer, but by someone else decades later after Vermeer had died. Science revealed that Vermeer painted a Cupid in the background, now viewable in the restored painting. This new discovery adds a clue to the meaning of the portrait, suggesting that the girl is probably reading a love letter.